The derivatives of the inverse trigonometric functions can sometimes get a little bit lengthy, and I put the most common three here up just to start with. And what you can see, first off, I want you to notice that the inverse sine and inverse cosine are really similar to one another. The derivative of the inverse sine function is 1 over the square root of 1 minus whatever I may have put in there. So let me just remind you, this could be a function, and then I'd put the whole function in there, but then I'd, because of chain rule, have to multiply by the derivative of the function. And the inverse cosine, same idea. It's just the only difference is it's -1. Instead of +1, it's -1. So it's literally just the opposite. Inverse tangent, same idea with chain rule, but you can see here it doesn't have a square root, and it is 1 plus. Now, I just want to point out that, there are proofs for all of these, but all of these denominators should almost look like some kind of variation of Pythagorean theorem, because they are. And if you think about, if you had a hypotenuse and a side, you square and subtract. If you had two sides, you square and add. They're all based on Pythagorean theorem. Okay, so let's just do an example of each one of these so we can see how they work. All right, so in this first example, I'm going to find the derivative of the inverse sine of x cubed. So let's begin by just saying it's going to have a 1 over square root, and we're going to have 1 minus the function inside there squared, so x cubed squared, and then we multiply by the derivative of that function because of chain rule, and there we are. We certainly could clean this up a little bit. We could put the 3x squared on top, and we could have 1 minus x to the 6th. Okay, let's do the inverse cosine of the square root of x. So we're going to have -1 over the square root, 1 minus the function inside there squared. So square root of x, of course, squared is just going to be x. Now, this square root of x can be written as x to the 1/2. So when we go to find its derivative, we can use power rule. We can write 1/2 x to the -1/2. Just bring the power down and, of course, lower the power by 1. So this could leave us with -1 over, I'm going to have the square root 1 minus x, because square root of x squared. And then I have a 2 in my denominator from this, and also this x to the -1/2, because of that negative exponent, it will also be in the denominator. So we could just simply write, extend this maybe and write 2 square root of x or something. And we could certainly do some rearranging of this by, multiplying the square roots together, but I'm going to stop at that point. Now this last one, I kind of draw a line so I have some workspace, is the inverse tangent of the cosine of x. So again, just using our formula, we'd say, well, it's going to be 1 over 1 plus the function inside squared, and then multiplied by the derivative of that function because of chain rule. And we could clean this up a little bit, I guess. We could say it's negative sign on top and cosine squared, but I'm going to stop there. Again, these are worth knowing and worth remembering, and just be very careful of your algebra and make sure you use your chain rule. If this video helped, please like and subscribe for more math help.